Hi, this is Adrian from Live to Learn Academy, and today we're going to be going through lesson 9.3, combining two functions, specifically the products of these two functions. Now, for those of you who are new to this channel, we post videos like this every Monday to Friday at 3 p.m. Eastern, going through the advanced functions textbook. If you're somebody who needs tutoring, feel free to click the link in our description. It'll take you to our tutoring website, and from there, our team would love to get in contact with you. But without further ado, let's get straight into it. So guys, let's talk about this lesson. We're doing combining two functions with products. Now, what are products? What does products refer to? Products refers to multiplication of the functions, okay? So we're taking two functions and we're multiplying them together. Now, in your course, they're going to ask you to do this one of two ways. They're going to ask you to show it algebraically. That's one way. And the other way they're going to ask you to show it is graphically. Okay, so we need to know how to do both methods, right? If you want to know how to add and subtract them, feel free to look at lesson 9.2. It'll go there. And then for 9.4, we'll go through how to divide these two functions, okay? But for this lesson, we're doing multiplication. So let's look at this specific question. It says, let f at x equal x minus 2 and g at x equals x squared minus 4. And it says, develop an algebraic and a graphical model for each of the following. So the first thing that we want to do, guys, is we want to multiply these two functions together. So if I take this function and I make f at x equal x minus 2 and g at x equals x minus 4, I have this function. But here's the thing. I want to put this on a graph. Now this is where we have to draw back concepts from previous units. Remember when we were doing graphing polynomial functions? That's where that concept is going to come back here. So if you look at this, I'm going to just factor this out because I see the difference of squares with the x squared minus 4. So the x squared minus 4 is going to give me the x minus 2 and the x plus 2. And then I'm going to clean this up by making this x minus 2 squared and x plus 2. Now there's a couple key features in a graph that we need when we decide to actually put it on the graph, right? Couple key features are the leading coefficient, which is 1. And it's positive. And the other thing is the degree. The degree of this function is 3 because we have 2 and 1. So the degree is 3. So if we have a positive third degree function, which quadrants is it going to go through? It's going to go from quadrant 3 to quadrant 1. So these are like things that, we're drawing knowledge back from our previous units and we're bringing it into this unit. And you're going to have to do a lot of this when you get that new function after multiplying f at x and g at x. Even in the next unit, when you divide the functions, you're going to get a new function and you're going to draw back on your knowledge from polynomial functions. Okay? So the first thing I want to do here is I want to actually find out what my zeros are. So I know that from this guy, I'm going to have a 0 at x equals 2. And from this guy, I'm going to have a 0 at x equals negative 2. So why don't I put those zeros up here first on the graph? But the behavior around the 0 depends on what? It depends on the exponent. So this 2 refers to a bounce, and the 1 refers to a straight. And this is all from, graphing polynomials. A good practice, guys, when you're graphing these, yeah, we want the leading coefficient, the positive, the negative, the degree, the quadrants, which degrees are a bounce, a swivel, straight. We want all these things. But another thing that's a good practice is for us to get the y-intercept. So the way we get the y-intercept is we set x to equal 0. So our y-intercept becomes 0, 8. And this is good for just helping us graph it a bit better and more clear. So that's where our y-intercept is. Now we can graph it very seamlessly. We're going to start in quadrant 3. We're going to go up. And then we're going to bounce off the 2. And then go like that. And that's how we would graph our function. So the main thing, guys, you take the two functions, you multiply them together, you get a new function, and then from that new function, you go back in time with your knowledge of polynomial functions and you graph it as such. Okay, now I want to give you guys another question, and this is a question that I've seen on tests, okay? So, you may want to try this video out. You can pause the video and try it out yourself, but I'm going to go through it here because it's a very common question, and this is usually in the thinking section of your test, okay? So let's look at this question. It says, given the function f at x equals ax squared plus 3 and g of x equals bx minus 1, the graph f at x times g at x, so we're multiplying them, goes through these points, -1, -3, and 1, 9. Okay, so this is what we're going to do. First, what we're going to do is we're going to say f at x times g at x. So we got ax cubed plus 3 and bx minus 1. And now what we're going to do is we're going to create two equations. One of these equations is going to be using this point, and the other equation is going to be using this point. Okay? So let's first find out the first equation. So for the first guy, we're going to have -1, -3. Actually, I'm going to switch these two. It's going to make it a bit easier for us because I want to start off with the positive. Okay, so you got 1, 9 and -1, -3. So 1, 9, I'm going to say this is 9, and then here a times 1 squared plus 3, b times 1 minus 1. So you get 9 is equal to a plus 3 and b minus 1. So this ends up becoming your equation, okay, when I plug in that point. Now we got to do the same thing with the other point. So I'm going to say -3 is equal to a -1 squared plus 3, b -1 minus 1. So what we're going to get here is this is going to be a plus 3 as well. And this one is going to be -b minus 1. Okay, so over here we got two equations. We got equation 1 and we got equation 2. Now, one thing I want you guys to notice between these two equations is we're going to have to perform some kind of magic substitution, to get the value of a and get the value of b, right? But it's a little bit different from a traditional substitution or traditional elimination. One thing you want to recognize in this specific question is they both have a plus 3, right? This is a key finding. And the reason I say this is because if I take the first function and I actually divide it by the second function, I will effectively be able to cancel out those a plus 3's. So if I have 9 is equal to a plus 3 b minus 1 divided by -3 a plus 3 -b minus 1, what I'm going to end up with is 9 divided by -3 will be -3. The a plus 3 will cancel, and what I'm going to be left with is the b minus 1 over the -b minus 1. Now, this is a order of operation that you may not actually think to do, but this is how you do it, okay? And I've seen this on a test, so you're able to do this if you can recognize that there's an a plus 3 in the first equation and the second equation. Now, from this, it gets a lot easier. This is really, the hard part. Now, what we're going to do is we're going to bring this over to the other side. So -b minus 1 equals b minus 1. And then we're going to expand it out. So 3b plus 3 is equal to b minus 1. And then we have 2b is equal to -4. b equals -2. Boom. And there we have the value for b. Now what we got to do is we got to take this value of b, plugging it into either the first equation or the second equation to get the value of a. So I'm going to plug it into the first equation. So we know that 9 is equal to a plus 3 b minus 1. And I'm going to plug that value in. So a plus 3, and then b is negative 2 minus 1. So 9 is equal to a plus 3, negative 3. Divide out the negative 3 on the other side. We get negative 3 is equal to a plus 3. Negative 6 is equal to a. And there you have it. You found your b value and you found your a value. So this is a very, common thinking question where they'll give you two functions, they'll teach you how to multiply it, and then from there, they'll give you 2 points. And all it is you're getting the multiplication function right here, and then from there, you plug in 1 point, get an equation, you plug in another point, get an equation, and then you do an order of operations such as a substitution or elimination or this kind of dividing of functions, right? You have to do that order of operation to get one value. Once you get the b value or the a value, whichever one you isolated for, then you can plug that back into one of the original equations to get the other value, right? So hopefully this made sense to you guys. If you guys do have questions, that you want me to go through with this particular unit, feel free to send it to me or comment below. Like the video and feel free to subscribe to more videos like this. But without further ado, I'll see you guys in the next video.